Hi, Amanda.
And I'm Dean, and welcome to Scientists Talk Movies. Tell me a bit about how you became a scientist.
Yeah, I originally actually wasn't planning on being a chemist. I had learned and studied music for a really long time in high school. I thought I was going to go to conservatory, and long story short, that didn't work out, and I decided to go to college and be pre-med because I thought that that would be a more functional major as opposed to being a musician. And then that actually didn't work out. And by the last year of my undergraduate education, I made a split decision to just go full Chem GRE and apply for chemistry grad school. There are a lot of factors that influence this decision, but overall, it was a very circuitous way. And with most things in my life, I never really arrived at that destination, going from point A to point B in the most direct manner. It was always like stopping in other areas of my life before I ended up being in the place that I really belonged. So that's how it started for me. How did it start for you?
Similar, although I don't play an instrument. I got where I am today by making a lot of mistakes and taking a lot of wrong turns, and I wouldn't change it at all. I mean, I thought I wanted to be a physicist at one point, but I'm not so good at math. And I actually had a short organic chemistry class in high school, which made me want to be a chemist, even though it was all about nomenclature, which is something I hate. And I went to grad school because I liked chemistry and couldn't think of anything else to do. So, and then it was only partway through grad school that I discovered that I liked a certain kind of research, and that led me to, do what I'm doing now. So I don't think, my career path is at all a good example of advanced planning. It's more a tale of keeping your eyes open and being willing to change your course as you go forward. On your path to where you are now, did you have any movies or TV from when you were a kid that you think influenced that?
The thing about chemistry that always attracted me to it as a subject is that everybody just found it to be really, really difficult. Like the senior classmen in my high school would complain about it, and that just kind of set up my whole ideology on chemistry and how I wanted to approach it. Because once they said that this was like the hardest class that they'd ever taken, I was really I wanted to kind of dedicate myself to doing well at it. So, and I don't know why that psychologically was the case, but that's kind of what's got me started on it. And the other aspect of it is in pop culture, chemistry was kind of known as to be the class that like everybody was afraid of. And like, for example, in Harry Potter, which is one of the film series that I grew up watching and I love dearly as a series, um, you know, potions is probably the closest class to chemistry from the magic world or the wizarding world of Harry Potter. And actually, J.K. Rowling at the time had come out in an interview and said that she had based the character of Snape, who's the potions professor at Hogwarts, on a really bad experience she had with a chemistry teacher in her education. So from then on, like after I saw kind of the interpretation of the world on the big screens and just how magical it all was, it kind of added that level of interest because I feel like what I do is doing magic, but in real life. So, or it's the closest thing to potions anyway.
I don't really remember any movies about science or scientists when I was a kid. I'm older, and so I was a Star Wars kid. So I was 3 years old when the first Star Wars came out, 3 or 4. And I, of course, loved it like everybody did. And for me, it wasn't about Star Wars. It wasn't about science, and it wasn't really even science fiction. It was more fantasy, but it was all the technology in that movie coupled to the storytelling that I think, at least subconsciously, kind of drove me towards the science side of things. And when I was, much older and realized that storytelling has an important place in real science, then my head almost exploded. That was a super important thing for me in terms of my career, to realize that storytelling is super important, and it should not be separated from science.
And it's amazing that they're able to communicate things and concepts that are kind of really far-fetched and like completely out of their imagination, right? For somebody like George Lucas. So I find that that's actually a really good groundwork when you look at sci-fi writing and fantasy writing to describe science, because to a lot of people who are reading your papers, they might not necessarily know exactly what you're talking about. But if they're able to communicate to a general audience who's never seen Star Wars before, what the world is like, then we could probably communicate pretty complex scientific theory as well.
I would say most people don't know this about me, but I've actually started writing sci-fi flash fiction. You can try to find it online.
I
But
think there's a link on your website.
there might be a link somewhere. As I've gotten older, the lines between different media have blurred more and more and more, right? And I love that, right? I'm not the kind of person who just focuses on one thing. I love to jump around between things. And maybe that influences the kind of movies I like to watch. I mean, the whole thing about the Star Wars movies was the pacing was so fast. I mean, it's slow by today's standards, but it's because of Star Wars that, the quick cuts back and forth, the processing of all those different things is kind of how my brain likes to work.
That's really cool that you bring that up, because I know that I reached out to you to talk about maybe symmetry in this discussion. And that's one of, like, I think the most obvious representations of that back and forth cutting between, I think, the birth scenes and then
yes, I wanted to talk about this. We didn't talk about this in advance, but yeah, okay, so we're turning this into the Star Wars podcast now.
Yes.
Which is totally fine, I suppose. But one of my favorite examples is from the prequels, which a lot of people don't like. In episode 3, which was, of course, the 6th Star Wars movie, at the very end, there is a scene where sort of Darth Vader is being born. Anakin has been crisped up in lava, and he's being put into his suit. So Darth Vader is being born, and Anakin is dying, and that's intercut back and forth with Padme dying as Luke and Leia are being born, right? And it's a symmetrical thing, but it's also a direct tribute to the end of The Godfather, which is one of the best movies in history, where there's a baptism of Michael's, I think it's his son being baptized, which is intercut with the heads of the 5 families being murdered, right? And it's the same kind of intercutting. The juxtaposition of those things in a symmetrical way has a big impact, I think, on what you take from it.
And I really like the connection that the symmetry in terms of the cutting back and forth also has with the narrative. Like, so as one chapter or one story dies, usually, something else is born. Human beings, we don't really want something to truly end. So a lot of the questions that I had when I first, reached out to Summer and Kelly about doing this is, why is symmetry so appealing to people? And can we talk about it or think about it from an evolutionary standpoint? And a lot of times I think it's, visually it makes sense. The research that I've done on it, everybody says that it's because it's very comforting to see something symmetrical. And your brain doesn't have to work as hard to process something symmetrical because they're all repeated units. So I think that might be an interesting groundwork from it. But I also think, narratively, as human beings, we're really resistant, I think, to having something just end. And so we like patterns. We like stories that kind of retell themselves. The Star Wars, trilogy that became more than a trilogy, and several trilogies, I think, is a good example of that, because people don't want Star Wars. Yeah, it's a trilogy. And who knows, it might be like a trilogy of trilogies by the end of all of this.
Well, you hit on several important things, I think. So you pointed out, I think it's important to define symmetry, and I would say symmetry is just repetition, right? And in a movie or a TV show, it's interesting. It's generally more pseudo-symmetry, right? Or almost symmetry. There are often repeating parts, but they're different in little ways. And it's those little differences that draw your attention, I think. I mean, it's the same thing with macroscopic objects and with people. You know, there have been scientific studies that show that perfectly symmetrical faces are less appealing than slightly unsymmetrical faces, right? And so I think you're right. Symmetry is comforting, but perfect symmetry can be disorienting a little bit, and it almost feels a little unnatural. And I think that is used to great effect in storytelling and in movies.
The whole object of symmetry being in storytelling is that it can sometimes highlight when there's not symmetry, and when there's an abrupt disruption, I want to say, to the symmetry that you see on the screen, it ends up creating, different feelings or different tones to the movie. So like the two examples that I really like to talk about and compare is that Stanley Kubrick, who's the director of The Shining as well as 2001 Space Odyssey,
Yep.
he loves using symmetry in all of his films, and I think he typically uses symmetry to convey a mood. So in 2001 Space Odyssey, it's a mood of being in outer space and being in technology, and kind of being outside of the bounds of life, so to speak. And then in Shining, it's definitely used to convey a sense of eeriness and something's not right. And which I think that's just really fabulous. But if you contrast that with kind of Wes Anderson's approach to using symmetry, so a lot of Wes Anderson's films, like the Royal Tenenbaums, Grand Budapest Hotel, he uses the disruption of symmetry for comedic effect. So there's really a lot of different ways that films, I think, can utilize symmetry to convey a story. And similarly, I think in our work, it's like, when we have something that's symmetrical, it's funny because almost like that's the most aesthetically pleasing, and we like to analyze symmetry. But ultimately, the goal of a synthetic organic chemist is to get to something that's asymmetrical more often than not.
Yeah. Mm-hmm.
So I kind of like that contrast as well between like the two elements of work. So I think about symmetry a lot in both my film studies as well as my chemistry studies, evidently.
I think since we haven't mentioned Star Wars in this part of our conversation, I'll mention another Star Wars one. When you say symmetry in movies, people, I think, first just think about the framing, right? The visual symmetry. There's a scene where they're in the trash compactor, right? And it's also symmetrical. The walls are it's not as symmetrical as I think they wanted, but the walls are closing in, okay? Right? And it's two walls squishing, right? So then when you get to the trench scene, you have that same feeling, right? The walls aren't moving, but you're stuck between two walls, and it creates tension. That's usually subconscious, I think, but it creates tension like the walls are closing in on Luke, right? And that's the kind of thing that, some people say that's overanalyzing, but as far as I can tell, that is all done on purpose, right? And people should assume the same thing for scientific papers and scientific presentation.
It kind of leads me to think about the next point, which is that in scientific writing, you can go too far. And one of the reasons why you can go too far is because you haven't necessarily, like you said, you need to have everything mean something. You have to think about the word choices or the order in which you're presenting the information. Like, we are comparing films a lot to scientific writing, but it's not to say that you can just go crazy and be the most creative you can be in scientific writing. There is still a structure there that needs to be followed. You're still trying to communicate something that's very different from what films are trying to communicate. But what you can learn from a lot of films is like they are very selective, because there's a lot of different things that you can do in film, but they're going to choose to do certain things so that you get the maximum takeaway from that film. And I think that we as writers, and this is something that I'm still working on, need to choose certain words or certain things that you're conveying to kind of keep the focus on what you're writing now more than ever, because there are so many publications and so many journals than there used to be, so it can all be a little overwhelming. Yeah,
I agree with you completely. If you look at how movies are made, that it is exceedingly rare for a movie to be made where someone writes the script and only the scenes in the script are filmed, and all of them are filmed in the order that they were written, and they're all just tied together, right? There's a lot of being out of order. There's a lot of rearranging things. So this scene I thought was going to be at the end, but I'm going to move it to the beginning. That makes a lot of sense, right? Ultimately, you're sort of serving the story. You're changing how you tell the story when you're getting closer and closer to the final product. And I worry sometimes that scientists feel like they're constrained and they have to get everything in the right order from the beginning. And I think you need to let go, not you personally, but you, the general you, need to let go and be willing to move things around. Take something that was going to be the end of your paper, put it near the beginning, see if it works better there, right? It's up to the scientist to put the story on the facts. And I don't mean, change the meaning of the facts, but the way that you present it can make those facts more or less accessible, more or less interesting to the audience, right? And I don't see any reason why you can't approach it in a similar way. I mean, I say all this, it's not like, oh yeah, as soon as I went to grad school, I started thinking about writing papers just like I would make a movie, and not at all. I mean, it's more in retrospect that I've realized that those two parts of my life have kind of trickled into each other. But I think that is a really useful approach, being willing to let go of your initial conception of what the story or what the structure is. I mean, I get really upset, for example, when a journal tells me the experimental methods part has to be at the end of the paper. It can't be after the introduction, right? And I feel like, well, for a computational paper, it needs to be before you talk about the results, so you could set people up to assess whether or not you should believe the results. So, but there are still some journals that are stuck in a particular structure, right? In a sort of one size fits all kind of structure.
It's just interesting because the other day I was reading on Twitter, there was like a really massive thread of somebody started it because they wanted to know what words were your pet peeves if you ever see them appear in a journal that you're reviewing or an article that you're reviewing. And a lot of it made a lot of sense, because if you can come from a camp of writers that believe that you need to be as empirical as possible, so don't over flourish your writing and don't add unnecessary details to it, which there are a lot of pros to that. You don't want to, again, add unnecessary details or flourishments that you don't need. The other camp of it is that I think you need a certain level of creativity. I think that's kind of where you're coming from. It's like you've got to think outside of the box sometimes, because a lot of the problems that you're solving as scientists are kind of out of the box. And then you have to design a story or design a structure to your writing that conforms to the project that you're working on, which might not necessarily benefit from the same structures that you've commonly seen. So what I like to do when I write a paper, if I write, is that I look for another paper that's investigating a similar problem, and I kind of see how they present the evidence, so to speak. It's almost like a whodunit video, a whodunit movie. And I look to them to see how they structured it, and that kind of gives me some idea of how to construct the narrative. Just like, a lot of filmmakers, if they're making a film about a certain story, they're going to look to previous films that have had to do the same type of genre or the same type of main character or same type of issue to see how they can explore that better. So I'm with you. I'm actually also very passionate about looking behind the scenes and seeing what the director or what the editor really is thinking when they're doing certain cuts or making certain decisions. I think that complexity is awesome. I wish we had something that was analogous to that, but maybe for like paper writing, like just take a bunch of people with very successful papers, define success as you will, and see how they approach writing, because I think that's not something that's usually taught in graduate school, for instance.
Yeah, well, there isn't one way to do it. When I was a grad student, I was part of this thing called, it had a really snooty name. What was it? The Collegium of University Teaching Fellows. But it basically
Very
allowed
snooty.
you to create your own. It was like our freshman seminar program here at Davis, but you could create your own class. And ironically, I created a class about symmetry. But we had this meeting where everyone who was in this program, it was 10 or 15 people. And at the first meeting, people were talking, it was about scientific writing or about, scholarly writing, because it wasn't just scientists. And someone went on and on for like a half an hour about how they plan everything out in their head. And the only way to do it is do that. And you write it down and you start writing, and then you get to the end and you're done. And I never spoke up in scenarios like that, but I'm like, I do it. That's great. I do it exactly the opposite. I just throw everything down and then I rearrange it all later. And they couldn't comprehend that. The other thing you said made me think about, how you looked at other papers for structure. And I think we should do more, how to say, tribute papers. I
Yeah.
said that scene in
Throwback
Star Wars
papers.
was a tribute to the Godfather, right?
Yeah.
Well, I would now you've made me want to write a paper that's like a tribute to Roald Hoffmann paper from the 60s or something, and see if anyone notices. I had plans with a friend from grad school to write a paper in the style of Dr. Seuss. We never get around to it. Someday we will. Okay.
Yeah.
I'm sure you can appreciate that, but
I can.
What is wrong with letting people know that scientists have fun? I don't think there's anything wrong with that. What was the word you used? Flourishments. I'm all for flourishments if they have a purpose, right? If you want to draw attention to something particular, that's great. My postdoc advisor, Roald Hoffmann, was always getting dinged for too many flourishments in his papers by reviewers who thought it should be much more businesslike. But he fought against that and pushed for that. And I think it was great. The only advice I ever got as a grad student about writing a scientific paper was from my PI. He brought me in one time and he said, okay, you're a good writer, but your writing is like this. And he just drew a straight line. He said, your writing should be like this. Pow, pow, right? It should build up to these high points and relax and then make another point. It shouldn't be completely level. And to first of all, I was like, oh no, I'm being criticized by my advisor. But then after that passed, I felt, yeah, that's right. Why feel like science has to be sort of monotone when you can use the structure of a paper to convey a message and make particular points and emphasize particular aspects of what you're trying to convey. I would love to do, maybe I can talk you into this sometime. Maybe we'll create a class, is give 10 people the same scientific results and have them all independently write a paper on those results. And
that
then
sounds
compare and contrast and talk about it, right?
That sounds like a great idea.
I mean, that would just be like giving, film students the same footage and saying, make a movie out of this and see how different things are, right? I think that would be really fun.
I think that would be really fun because I think too often, if you didn't have advisors like that, I think in your PhD career, then you're never going to learn this, which is that, if the main goal is for somebody to finish your paper and get to the conclusions and really see the results, then you got to keep them, if you have something that's completely deadline like this, then they're never going to, I think, continue reading it. And the film industry really will feel the impact of this because they will have less people going to the box offices. So they know that they need to have this rhythm. But as writers, I feel like we don't, or I guess as scientific chemists, some of us might think that we're kind of boxed into this, you're doing research, you got to report everything as is, and you do, but you have a little bit of creativity that you can explore, like how you report a certain set of results. You can choose what to emphasize, right? And that's the other beauty of it, which is that this is your project, so you get to choose what you think is important. And hopefully your reviewers also think that's important, but first you need to be able to show the reviewers that. So yeah, that should be a very helpful class.
Yeah, I mean, I know. I obviously don't have the time to teach it, but I will. I will file it away for someday. I know some people who give great presentations on their research and write the most boring papers, and that always blows my mind, right? Because they're the same. You're telling the same story, right? The same thing with teaching. You've taken my class, you've TA'd my class. The students who join my group generally take my class, the physical organic class, before they ever see me give a talk. And then at some point in their career, they'll see me give a scientific presentation. And without fail, someone afterwards will come up to me and say, wow, I was surprised. That was just like your class. And I'll say, yeah, why should it be any different? Right? And that's how our papers are written, right? It's all, they're different media, so you do some things different, but it doesn't have, one has to be boring and one has to be exciting. They should all be exciting. you have to think about your audience. So many people write papers, scientific papers, for themselves, right?
It's true.
What they would want to hear. But you already know the story. You have to think about your audience. And it's obviously much less common in movies and TV, because that's much more focused on the audience, maybe too much, right? Because I feel like I'm a small segment of the audience that isn't, the big, what the most people might want to see. But a focus on the audience is super important in anything you do when you're talking to an audience.
That's storytelling 101. So I think you're preaching to the right choir. It's just it depends. In your undergraduate education, if you're somebody who is really into science, you might not necessarily really taken a creative writing class or done anything outside of that. And communication and scientific communication is now such a big facet of the job that
Yep.
by the time I think a lot of us come into grad school, we're kind of really unprepared for it. Like, I have a lot of feelings about it, but I don't think I execute a lot of the same kind of things that I think about as well as I should. And it's
Mhm.
just gonna unfortunately have to come from practice and trial and error at that point.
I'm going to make a recommendation. There's a guy named Alan Alda, who I mentioned Alan Alda to some of my students the other day. They had no idea who he was, but he was on MASH, arguably the best sitcom or ever, probably the first dramedy that was both sitcom and drama. He's not a scientist, but he's fascinated by science, and he's dedicated the last couple of decades of his life mostly to improving scientific communication, specifically with the general public, but also between scientists. And he set up the Alan Alda, I forget what it's called, the Institute for Scientific Communication or something like that at Stony Brook College in New York, and Stony Brook University in New York. And he always makes scientists do the same thing when they take his programs. He makes them do improv, okay? Which
That's a
sounds,
good idea.
it sounds horribly scary to me, okay?
It is.
But the whole point of it is, anyone who knows anything about improv knows that improv, the golden rule of improv is yes and. So someone says something to you and your attitude should be yes and. How do I build on that, right? Improv forces you to focus on someone else. That's something that I think scientists have a hard time with. We live in our own little world and we're so focused on what we're doing that just making scientists do that opens people up to thinking about the audience, thinking about other people in what you're trying to perform. He has a fantastic blog right now. It's all about communication in general. So people should look at that.
We'll include a bunch of links in the YouTube description or something, because there's probably going to be a lot of links here that we want to discuss. Thank you so much for having this conversation with me. I really appreciate it. It's always fun talking about film and writing in general. And hope you guys look forward to the next one.
Bye-bye, everyone.